This is a demonstration of virtual collections integrated into a clone of the Cornell Discovery and Access System. As this is a demonstration, it is not production level code, but serves as a proof of concept of the viability of using linked data to manage virtual collections. I will point out challenges and strengths of this approach as we step through the demo. At this point, we are looking at the main search page that is part of the Cornell Library Discovery and Access System. It has only one modification from the live version, and that is the addition of this My Virtual Collections up in the menus. In this demonstration, we're going to be exploring the integration of the Ruby engine for creating and managing virtual collections. This work was developed as part of the Linked Data for Libraries project. The engine works with linked data in two ways. It uses ORE ontology to store the structure of the virtual collection, with ORE classes and properties being used to track RDF related to each virtual collection that we create, and the items that are created in the collection. The engine also uses open annotation ontology to allow users to make comments and user-generated tags for items in a collection. The second way the engine interacts with linked data is in the process of gathering information about the items. It is able to interact with libraries that publish linked data in recognized formats and extract the key pieces of information needed for discovery of the resources within the virtual collection system. If linked data is not available, but the library makes MARC XML available in a known format, then the system is also capable of converting the MARC XML to BibFrame RDF, and from the BibFrame RDF, it will extract out the discovery required metadata. When interacting with the Cornell system, we leverage our access to the internal Solr index for Cornell library resources to extract the information we need directly from the Solr index. So let's take a test drive. We're going to click My Virtual Collections. And on the left-hand side, had we had any collections, they would be listed here. So let's go ahead and add one so we can see that. We'll be adding basic metadata. So now we can see that archery shows up under My Virtual Collections. And you'll notice right below that there's a section called Watched Collections. This is future functionality where a user will be able to search and find other people's collections that they've created and be able to keep them in their watch section. This would be used for something like a student who's in a class and the class has a reading list that's being managed as a virtual collection. Now that we've created the collection, the triple store has ORE aggregation triples related to the collection itself. And at this point, it doesn't have any resources in the collection, so let's go and add one. So I'm going to do a search, and this is the same kind of search that you would do through the regular library catalog system. And it's going to return some resources on archery, and I'm going to select the second resource. If we were in the regular catalog system, you would not see this add to virtual collection. So you'll notice this is just the regular catalog entry with all the additional information that is part of that. So now we can choose to add the resource to the virtual collection. We're going to select the archery collection that we just created. And then it's over here now. So under My Virtual Collections, we can now see that we have the archery steps to success. And you'll notice that there's some metadata that comes over with that. We have the title, we have the author's name, we have publisher, and we also have the fact that this came from the Cornell library system. The resource is now listed as a member of the archery collection. As part of the process of adding the resource to the collection, a resource triple was added to the ORE aggregation. The system uses the library catalog URL as the URI for the resource. What this allows us to do is if we click the title, we'll actually go back to the original source. And we can go back to my virtual collections archery. For each item that we put in the collection, there will be an ORE proxy that is also created. And the proxy points back to the collection, says this item lives in this collection, and it's also the place that we're caching the metadata. This is especially important when we're working with external resources, which we're about to add. We do not want to have to retrieve the external information every time we want to display a particular item. At the same time, this does add the complexity of managing the cache and ensuring reasonably frequent updates of the cache from the original source of the metadata. Cornell metadata is extracted directly from our Solr index. For external resources, we use content negotiation to request linked data, and in some cases, as mentioned previously, we'll get MARC XML back. So now let's see how we do an external resource. We're going to go over to Stanford's SearchWorks. And this is searching their live catalog. And we'll just take the top resource that they have listed. Stanford is one of the universities that provides MARC XML. So in this case, we're just going to take the URL, and when we do content negotiation on that URL, it's going to return to us the MARC XML. And in the process of retrieving the MARC XML, it's going to convert it to BibFrame and then extract the metadata that we need from BibFrame. And then you can see here that we now have a resource that comes from the Stanford catalog. We can also pull information from WorldCat, from OCLC. OCLC provides its linked data in the form of schema.org, and it provides a permalink that we can use for the content negotiation to get the triples. So we can see now that the OCLC WorldCat resource is also now part of our collection. And the last one I'm going to demonstrate is getting information from Vivo. I've already done a search here for archery, so I'm just going to grab the permalink for it. Vivo also serves up triples when you do content negotiation on its permalink. And now we have the Vivo resource in there as well. There are some limitations to the ability to add resources through the external URI process. The system must know how to interpret the set of triples that are returned by the content negotiation process. In the examples we presented here, all three systems return a completely different set of triples. To address this, the system has modules for processing various common sets of triples. The host URI is registered along with the process required to extract triples by that particular host. This is a flexible approach to the problem, but it requires a new module to be created for every novel set of triples that we encounter. The viability of linked data will greatly increase when libraries use a standard set of triples. At that point, the metadata can be extracted using a single process, regardless of which library we're getting the resource from. So this is the basic functionality that is available for adding resources one at a time, which is only applicable to small-scale virtual collections. So that would be things like creating a reading list or having collecting together resources for a particular research project. But if you want to create a large-scale virtual collection for the library itself, where the scale would be more on the line of hundreds of thousands of resources, then we need to take a different approach. We are working to scaling to larger collections. This work includes allowing users to specify rules for selecting items. Rules can specify ranges of call numbers, ebook identifiers, librarian annotations that they put on particular resources, such as engineering handbook, and also bringing in other virtual collections so that you can create a larger virtual collections out of several sub-collections. When this functionality is put in place, the user will be able to add these rules either at the time they create the collection or afterward to sort of expand on the number of rules that they have, or even to remove some rules. In preparation of that, we have already developed some functionality to select resources by a query, and I have a query that we can use to demonstrate this ability. So we're going to do add by query. And in this case, I've said call number matches GV1185, and that should bring us in some archery resources. One of the things that I did is I actually limited the query to 5 resources just so that it would execute efficiently for the demo. So there you can see we have included in several other archery related resources by executing a query. And this is the same kind of query that would be executed if we wanted to gather resources by call number range. And in that case, you could bring in many thousands of resources by executing a single query. So I do want to show one more piece of functionality. I mentioned earlier that we have the ability to do annotations. So we can create a free-form annotation. So at this point, we have an open annotation set of triples that represents a free-form note. We can also do the same thing adding tags. And we can specify the tags by separating them by semicolons. That will create multiple tags. Under the covers, this created 3 annotations. It created a note annotation and 2 tag annotations following the open annotation ontology specification. This concludes the demonstration. You can go to LD4L.org to get more information on the grant and to see other work being done to demonstrate working with triples across 3 library systems.